Let us now do an example problem. The heat of fusion of water is 6.02 kilojoules per mole. How much energy is required to melt 50 grams of ice into water? So if we look at the heating curve, we are starting here 50 grams of ice, which is at 0 degrees Celsius, and we need to calculate the amount of heat required to completely convert that 50 grams of ice into 50 grams of water, which is up to here. So, according to the question, we need 6.02 kilojoules of heat to melt 1 mole of ice to water at 0 degrees Celsius. However, we have only 50 grams of ice, and we are supposed to calculate the amount of heat required to melt 50 grams of ice. So, first I convert grams of ice into moles of ice, and then I convert moles of ice into kilojoules of heat required. So let us start with 50 grams of ice. I multiply this with a conversion factor that has grams of ice in the denominator and moles of ice in the numerator. We know that the molar mass of water is 18 grams per mole. Therefore, this conversion factor becomes 1 mole of ice per 18 grams of ice. Grams of ice gets cancelled. Next, I can convert moles of ice into kilojoules of heat required. To do that, I need to multiply this with a conversion factor that has moles of ice in the denominator and kilojoules of heat required in the numerator, which is 6.02 kilojoules of heat per every 1 mole of ice. Moles of ice gets cancelled, and if we do the math, we get 16.72 kilojoules of heat. This is the amount of heat required to melt 50 grams of ice into liquid water at 0 degrees Celsius. If you do not like to use the conversion factors, you can use the following formula. The heat required for a phase change is equal to the amount of substance times enthalpy change of that particular phase change. In this problem, enthalpy change for fusion is 6.02 kilojoules per mole, and the amount is 50 grams of ice, which needs to be converted into moles before using it in this formula. Let us do one more example. The heat of vaporization of water is 40.7 kilojoules per mole. How much energy is required to vaporize 50 grams of water into vapor at 100 degrees Celsius? Pause the video here for a moment and try to answer this question. So if we look at the heating curve, we are starting here with 50 grams of water, and we need to convert that 50 grams of water into 50 grams of water vapor at 100 degrees Celsius. So we are calculating the heat required to do this transition. According to the problem, the heat of vaporization of water is 40.7 kilojoules per mole, which means it costs 40.7 kilojoules of energy to convert 1 mole of water into vapor. And we have 50 grams of water that needs to be converted into vapor. So, first, I convert grams of water into moles of water, and then moles of water into kilojoules of energy. We start with 50 grams of water. Let's convert that into moles by multiplying it with a conversion factor that is 1 mole of water per 18 grams of water. Grams of water gets cancelled. Next, we multiply it with a conversion factor that converts moles of water into kilojoules of heat. That is 40.7 kilojoules of heat per every mole of water. If we do the math, we would get 113 kilojoules of heat required to convert 50 grams of water into vapor at 100 degrees Celsius. Let us do another problem. The specific heat of water is 4.18 joule per gram per degree Celsius. How much heat is required to raise the temperature of 50 grams of water from 0 degrees Celsius to 100 degrees Celsius? Pause the video here and try to answer this question. The heat absorbed or released and the temperature change of the substance are related to each other by the formula Q is equal to mc delta T, where Q is heat absorbed or released, m is mass, C is the specific heat, and delta T is the temperature change. If we look at the problem, the specific heat of water is given, the mass of water is given, the delta T, that is the final temperature minus initial temperature, is also given, and we need to calculate the heat absorbed. Let us plug in all these values in the formula. Again, mass is 50 grams, specific heat is 4.18 joule per gram per degree Celsius, and the delta T, that is the final temperature minus initial temperature, 100 minus 0 is 100 degrees Celsius. Grams and grams get cancelled. Degree Celsius and degree Celsius gets cancelled. If we do the math, we get 20,900 joules or 20.9 kilojoules. If we visualize this on the heating curve, we calculated the amount of heat required to convert 50 grams of water at 0 degrees Celsius to 50 grams of water at 100 degrees Celsius. So, in question 1, we calculated the amount of heat required to convert 50 grams of ice to 50 grams of water at 0 degrees Celsius. That is this change. In question 2, we calculated the heat required to convert 50 grams of water into 50 grams of water vapor at 100 degrees Celsius. That is this change. In question 3, we calculated the heat required to convert 50 grams of water at 0 degrees Celsius to 50 grams of water at 100 degrees Celsius. That is this change. So if I ask a question, calculate the amount of heat required to convert 50 grams of ice at 0 degrees Celsius to 50 grams of water vapor at 100 degrees Celsius, we can add these three heats up to calculate that. In the exam, you will get these type of problems. Just to recap, the heat changes for the sloped lines in the heating curve can be calculated by the formula Q is equals to mc delta T. Keep in mind that the specific heat of ice is way different than the specific heat of water and specific heat of water vapor. These three values will be provided to you in the exam. And the heat changes for the phase transitions are calculated by the formula Q is equals to amount time enthalpy change for that particular phase change. Note that the enthalpy of fusion and vaporization are given in the units of kilojoules per mole, whereas the specific heat is given as joule per gram per degree Celsius. So if the amount of substance in the question is given as grams, be sure to convert grams into moles when calculating the heat changes for phase transitions.